Here is an illustration of satellite ranging. When a satellite sends a signal, it creates a circle with a radius measured from the GPS device to the satellite. When we add a second satellite, it creates a second circle, and the location is narrowed down to one of 2 points where the circles intersect. With a third satellite, the device's location can finally be determined, as the device is at the intersection of all 3 circles. That said, we live in a 3-dimensional world, which means that each satellite produces a sphere, not a circle. The intersection of 3 spheres produces 2 points of intersection, so the point nearest Earth is chosen. How accurate is GPS? GPS device accuracy depends on many variables, such as the number of satellites available, the ionosphere, the urban environment and more. Some factors that can hinder GPS accuracy include physical obstruction. Arrival time measurements can be skewed by large masses like mountains, buildings, trees and more. Atmospheric effects. Ionospheric delays, heavy storm cover and solar storms can all affect GPS devices. Ephemeris. The orbital model within a satellite could be incorrect or out of date, although this is becoming increasingly rare. Numerical miscalculations. This might be a factor when the device hardware is not designed to specifications. Artificial interference. These include GPS jamming devices or spoofs. Accuracy tends to be higher in open areas with no adjacent tall buildings that can block signals. This effect is known as an urban canyon. When a device is surrounded by large buildings, like in downtown Manhattan or Toronto, the satellite signal is first blocked, and then bounced off a building, where it is finally read by the device. This can result in miscalculations of the satellite distance. Fortunately, many critical issues facing GPS technology have been identified and are nearing resolution. What are the uses of GPS? GPS is a powerful and dependable tool for businesses and organizations in many different industries. Surveyors, scientists, pilots, boat captains, first responders, and workers in mining and agriculture are just some of the people who use GPS on a daily basis for work. They use GPS information for preparing accurate surveys and maps, taking precise time measurements, tracking position or location, and for navigation. GPS works at all times and in almost all weather conditions. There are 5 main uses of GPS. Number 1. Location, determining a position. Number 2. Navigation, getting from one location to another. Number 3. Tracking, monitoring object or personal movement. Number 4. Mapping, creating maps of the world. And number 5. Timing, making it possible to take precise time measurements. Some specific examples of GPS use cases include emergency response. During an emergency or natural disaster, first responders use GPS for mapping, following and predicting weather, and keeping track of emergency personnel. Entertainment. GPS can be incorporated into games and activities like Pokémon Go and geocaching.